was going to say this man needs no introduction, but actually he does. So Pieter, our lead engineer, he's been with us for about 2 years now. Pieter is an amazing engineer who is in love with macros, and he's going to give you a very interesting presentation about this. So we hand it off to him.
Well, thanks, Nodar. I'm not that much in love with macros, and the reason for my speech today is actually that our dev row told me that everyone would like to know how the macro system works in Shuttle. And then Nodar asked how many people have used Shuttle before, and there weren't that many hands going up. So that means I'm at the wrong place or have the wrong talk. But on that note, can I just have the hands again? How many people have used Shuttle before? Okay.
2 minutes ago.
Nice. How many understand when Nodar mentioned infrastructure from code? Okay, that's a little bit better. Everyone understands infrastructure as code? Okay. Maybe for anyone in the room, if you typically have to add a database to an application, how would you do it as using infrastructure as code? Okay, and then you also have to set up this deployment and then connect to your database that you've set up. So what we do at Shuttle, I'm going to go to the end of my presentation so I can explain the start of my presentation. Yeah. So rather than set up this Docker file, you write your normal Rust application. And you annotate it saying, I want a Postgres database. And then you deploy this. And we automatically create the Postgres database for you. We connect to the Postgres database, and we give you a PG pool, and you can just use your Postgres database. Now, obviously the question is, how do we do all this? Hence my talk, the magic. So I can go back to the start, like any good movie. Yeah. And I want to cover 3 things: macros, CDKs, and unveiling the magic. So for macros, for those of you who don't know what macros are, they fall under a branch called metaprogramming. Metaprogramming again has 2 more branches. There is runtime metaprogramming. Reflection is a common example of this. And there's compile-time metaprogramming. C++ templatings would be another example of this. The metaprogramming that exists in Rust is the second one, compile-time metaprogramming. And metaprogramming is mostly seen as black magic that hides too much complexity from the users, and therefore it makes it this thing where a magic wand was swung around and something happened, like that last slide of something was deployed and connected and all of that. So I want to explain it. But before I go there, metaprogramming in Rust has 3 downsides, 3 major ones. The first is they are hard to debug. Simple reason being that that code hasn't been expanded yet, and since it hasn't been expanded, your debugger can't go into it and show you what's happening on the back end. Again, black magic. Compile times are longer, especially if you use proc macros. The reason for this is the way Rust or Cargo builds a project. It would take the metaprogram, compile it to a binary, a common interface that Cargo knows, then feeds your program to this binary just compiled, and then takes the output and replaces it in your program. The third problem, users usually have to learn something new. There's Rust, but then you might have to learn a new DLS or DSL, domain specific language, DSL, to understand this new thing that you're interacting with. Luckily, Rust kind of has converged into this convention where everyone uses the same thing. You'll see this mostly with Tokyo and Serde and all of the other grades. So why do we spend time making metaprograms or proc macros if we have all these downsides? Well, for the same reason we refactor our code so that we don't have to repeatedly write the same things over and over. We want to be dry. A simple example of a metaprogram that everyone uses on a daily basis is the Tokyo main. So annotating your main function with Tokyo main actually causes it to write a function similar to the one at the bottom. What it did, well, I'll get back to this. As to what it did, what it does is it expands into a new main with some setup calls. This is a builder pattern. I'll just go back. No, go back the other side. Never mind. That's a builder pattern that it uses to set up a runtime. It then unwraps the runtime and finally starts up something inside of this runtime. The way it does this is what's known in the procedural macros as it reads in the abstract syntax tree, it then reasons about it, and then puts out a new abstract syntax tree. In this example, it read in everything from this curly braces to this curly braces, generated all this, but then took those parts and just put them over there. And that makes it simple. It's like a function refactor. You realize you're going to have to repeat lines 1, 2, 3, 4, 5 almost all the time. You don't want to do it, so you just make a macro to do it for you instead. So that's macros. We have CDKs as well, unrelated to macros. But a CDK is what is known as a cloud development kit. It was created by Amazon to define and provision infrastructure in code directly. And number 2, it also deploys infrastructure or whatever you defined on CloudFormation. Now what I'm going to show you next isn't Amazon's CDK, but rather a hypothetical version of what it looks like inside of Shuttle. So what you have on line 3 is making a provisioner. Remember, the CDK is something that allows you to provision resources. So you get access to a provisioner. You then use a builder pattern and say, oh, I want to get access to some secrets. And then you tell it eventually on line 6 to build. And you pass in the provisioner telling it, oh, this provisioner now understands this configuration has been set up. I now just have to build it. It returns the secrets. And then using a proper refactor, your function might have an actual start at the bottom that takes in the secrets and does whatever it needs to with it. Now this is a simple example, because there's no configuration. Something more complex might be like this. Postgres, you need a database, but you also need to configure a database. And for some or other reason, this user wants it to run on port 5423. Don't know why, but anyway, there it is. Using the same border pattern, we can set up the config, pass in the provisioner. The provisioner knows how to build the Postgres from the configuration, returns the DB or PG port object, and the rest of the program can just use it inside of start. Now coming to refactoring. Between the previous slide and this slide, all of the code was the same, except for line 5 and 6. So if we were to refactor it, we just have to find a way to reason about line 5 and 6, and we can auto-generate the creation of the provisioner, the eventual building, and the eventual calling of the start function. And that's exactly what we do at Shuttle. So to unveil the magic, combining prog macros and CDKs, what we do is we take your definitions from the bottom, we see the namespace you're using, and we realize, okay, I can just use that namespace up here. That's the object on the namespace you're using. You're using new, so we're just going to call new. We're going to pass in the provisioner we created. This is your start function. We're going to make your start function again and just pass in the secrets. That's all we do when we expand the macros. Things get a bit more complicated for configurations, but they are mostly the same. We see the extra configuration you passed in on your object, and we just call a new method on the border with the arguments you gave the configuration, and everything works again. And that unveils the magic. Are there any questions?
Does the underlying CDK expose enough metadata that you can generate the builders and macros, or do you have to handwrite?
Handwrite the borders and the macros. Yeah, you have to handwrite. Well, no. There are two parts to this question, I think. As a user, you never have to write this. You always just write that. If you want to add a new resource that you can use over here, then we impose an interface your resource has to adhere to, so that we can call it over here.
Yeah. So if you were to, I don't know how structured the documentation is for CDK, because there'll be a whole load of offerings it offers. Can you generate from that?
Yeah, no, it's a hard problem to solve making it generic. No, it's very limited currently to what we can provision on our own platform.
Okay. Thank you.
I just wanted to ask, how do you, I was just wondering, how do you ensure that when you, let's say you've got a database, how do you ensure that the next time you run it, it's the same database when you want it to be, or a different database because you want to rapidly develop it, so you want to pull down when you run it, and then bring it up again when you've started up again?
Yeah.
Versus always having the same one. So let's say you deploy an update, you want it to retain the previous database. So how do you do that? Or is it a config option or something? Or
No, this isn't the actual code we have, so I'm going to expand what we really have. What we have at the end of this course we call give me your config. We then look at that config and realize, oh, this is a database, and we then look up if you've provisioned this database before. If you have, and the config is exactly the same, we skip the build step, and we already know what the settings are to connect to the database. If, however, you've now used another database, we won't find it in our stored versions of what you have had before, and therefore we'll just recreate it.
does that mean you sort of, do you have to sort of create by name, or is it more like fingerprinting where you match up all the values?
Yeah, more fingerprinting. We match the types currently. We think it's going to bite us in the butt eventually, because you can only provision one Postgres database or shared one, and you can then provision another shared MariaDB database for the same thing, but not two Postgres databases yet. You have to solve it.
Is the output of the macro purely Rust code, or does it also output, say, JSON into the kind of direction so you can see what you provisioned without running the program?
Currently, the output is just Rust code. We have been playing with an idea. We call this phase, or this is divided into two phases. We call the one the loader, which does everything above this line. And then everything below it we call the start phase. We want to get to a point where maybe we can generate two binaries. One binary has everything above, which is the loader. It then outputs a JSON, and that JSON gets fed into the thing where we check if these things has been provisioned before. From those we get the config of how you're going to connect, and then that generates another binary, but we aren't there yet. It's just something we're playing with.
So that looks like the development environment, right? So when you're looking at staging and prod, they're wildly different. There might be multiple electricity zones, regions, read replicas, so on. How are you seeing that work?
Currently, this already works for local environment. The reason being, we can control the provisioner. So locally, the provisioner does not connect to AWS, but it figures out from your Docker environment, oh, I can spin up this container, and then you have the exact same Postgres that you would have in production. In terms of staging, hopefully we'll be able to use the same thing, but we haven't tried to solve it yet. All the way back.
So, all of these configurations, usually with the database, that is in a network, in a VPC, in security groups, with a lot of stuff, right? That can go into lots of lines of configuration. In here we see the port. How do you address that? How do you have some configuration somewhere, or some defaults, or something that addresses all of those other variables that you need?
Yep. Yeah, since it's a border pattern, we always apply defaults. Currently, we don't really have a port setting. We just have a local URI for when you spin it up locally. That's to use maybe another Docker container or maybe something in staging. But yeah, the configuration is controlled by the resource.
Hi. You've saved 4 lines of code by using the macro.
Yes.
How many lines of code?
Only 4.
How many lines of code do you have to save before it becomes worth learning the DSL?
Don't know yet. But again, this is hypothetical. We have more on top of this setting up logging and a lot of other stuff. And this is actually about 10 lines of code. So these 3 lines or more, 10 lines of code.
I'll go with another question.
Obviously.
If you want to deploy the same application in different regions and have it connecting to different databases and so on, isn't it easier just to deploy different configuration files and have your application read configuration files?
Yeah, it would be. So far, we just try to stay away from configuration files as much as we can, but maybe we have to go there eventually, yeah.
Okay, but code is compiled. It doesn't change.
The configuration files. Oh, the...
Code. So if you want to deploy it quickly somewhere else, I suppose it will always be on port 5423. Or am I missing something?
No, I see what you're talking about. Well, yes. Again, this is just an example because I want to show ports and not something that you really expose, but we have to still figure out, coming back to the staging and local runs, we have to still figure out how you can give the config something that's more environment specific. We don't yet know what it is. What you mentioned about having config files might be the solution, but we don't know yet.
I suppose you could pass the config file to the macro.
Yep.
Any more questions?
This might be because I haven't worked much with Postgres and Rust before, but is the PG pull from like a Postgres crate?
Yes, SQLX in this case to be specific.
Okay, I guess the broader question I'd like to ask is how do you expect Shuttle to integrate with the rest of the ecosystem when it comes to external crates building on top of things like the PG pool type or something like that?
I know so far, if I'm correct, and if I understand the question correctly, there are crates, I forgot what the ORM is, that directly takes the PG pool and it can then work on it again. Another version that we might try eventually in the future is to have the resources more of a composite thing, a top resource exposing a bare minimum and then other resources building on top of that. But I don't know yet how we're going to solve it.
This might not be a super well formed question, but I've seen quite a few different approaches to configuration deployment, and I'm interested in, like, based on your collective experience, like what kind of opinions you've ended up forming about like what's terrible, what's great, and like what your direction you're trying to push this in. Like it kind of relates to the config thing.
Yes. No, I think this comes back to what Nodar said. We don't have a clear direction of where we should push this. The only driver we have is it should make it simpler for developers. If we see eventually config files might make it easier, then maybe that is it. So far we are only against something like that because you have to go into another file. It's not that close to your code.
Can we get Pieter a shout and then?
Sorry. If you were to pass the configuration in like a port number in as environment variables, would that work? At what point does this execute? Could you make the app sort of 12 factor if I pull out some old school terms?
Wait, quickly repeat the last part.
Could you make the app sort of 12 factor in the sense that configuration comes from environment variables? Like at what point does this code execute and decide specifically what happens?
This code executes, so I'm going to answer that part first. It executes when it starts up. We execute it, go until here, we stop it to finish all the loading of the resources, and then we continue the execution. What was the original question that I'm trying to answer?
Could you pass it in with environment variables? Is that a solution for configuration?
Yes. But also no. We've been trying to avoid environment variables as long as possible. What we do have is secrets, and we can interpolate for secrets in here.
Why does the Shuttleified version return a shuttle service, and can you leave it off?
Can it be off?
Yeah, can you just return void?
No. The reason it returns shuttle service is because whatever it returns has the logic for loading and starting up. It's not really a shuttle service, it's more like shuttle rocket, shuttle axiom, or some other framework.
I really like your approach because it allows to use the type system to check your deployment, which is something, it's a big problem usually when you build a new data center. You're missing configuration, you're missing environment variable, so that's the problem. Are you thinking to include in Shuttle something like the configuration of multiple data center as code, right? Because that's what I think is missing here, right? Someone said, what if you, like him, what if you want to pass different port in different data center, and you don't want to redeploy that code? What I think instead you should do, you should redeploy that code. That should be everything, right?
It makes sense. Coming back to the developer experience, it ensures the developer specifies what they need to specify.
Yeah, ensure the type system is aware fully of your infrastructure, so you can do, static type check. You can do static analysis on that. Have you think about any of this? Do you have any plan for anything like that?
We thought about two things there. The first is that's the reason we love having this here, not in a config file for the static analysis or static type checking. but it still leaves it hard to solve it for deploying to 2 places. There has to be a solution, but we don't know what it is yet.
Have you ever heard about Pulumi, which is an alternative to Terraform? They're exploring similar concept, right?
Yep.
Any more questions?
Do you support Podman? Rather, is your system able to determine the difference between like Podman or document?
You can run it on Podman, or locally it runs on Podman. You just have to make sure your Docker underscore socket points to your Podman socket.
Any more questions? Are you going to continue or?
That's mine. Thank you.
Great.